So by this point, you should have already seen the proof that any two even numbers multiplied by each other is always going to be even. If you haven't, you should go and watch that, because that proof already shows that this is already true. But let's say you don't want to prove that that for any two even numbers, the product of them is going to be even. Well, in that case, you might want to prove that any two of the same even numbers multiplied together is always even, or an even number squared is always going to be even. So this proof is going to look very similar, but there's one particular nuance you should pay attention to when writing proofs like this. So what should we do first? Think of some examples before you even assume this is true. 2 times 2, 2 squared, that's going to be 4. 6 squared, that's 36. 4 squared, that's 16. All of these are even numbers squared, and the answer is even. Okay. 0 squared, that's 0. That kind of covers most of the things that you should think of. You shouldn't think of numbers that are too large. So this is probably true. So let's write down the statement real quick. So because we're proving for any two of the same even numbers, so it's still a for all proof. So you write down for all a that are integers, we're going to just label this a. If a is even, then a squared is even. Okay, pretty straightforward. We have our P, we have our Q divided by our if and our then. Awesome. And we know it's a for all proof. So this is the statement we're trying to prove. All we need is our definition of even in this case. And how do we define even? Well, you've seen in the previous videos, the definition of even is an integer x such that x can be written as 2 times k, where k is an integer. Let me write that a little clearer. Okay, great. Now we can start writing our proof. So for all proofs, like I always say, you start with the word let. So you write down let, and we suppose a is an integer, and we suppose our p, right? So let a be an integer such that a is even. Great. More concretely, we need to define what it means for a to be even. So we'll say let a equal 2k, where k is also an integer. Remember, any new variable you introduce to your proof, you need to define it. Great. Now we can unpack this definition. So we can say a squared. We're going to try and show that when this is happening, we get something that's even, which means it has to be in the form of x is equal to 2k. So we start with a squared is equal to. We can unpack x. I'm going to be super explicit with my math here. So I'm going to say it's the same as a times a. Great. Which is going to be the same as, let's plug in our definition for a, 2k, close bracket, multiplied by 2k, close another bracket. Okay, now, could you show this is even? Yes, there's 2 ways of showing this is even. So I'm going to draw an arrow like this. From here, you can do one of 2 things. You can either pull a 2 out of one of the brackets, so then you will have 2, open bracket, close bracket, k, open your second bracket, and just copy what you wrote there. And there you go. And all you have to then do is say where k multiplied by 2k is an integer, right? And then you argue that, hey, this is our k, that's our 2, this is our x, so we have x is equal to 2 times this k. Okay, great. That's the first way, and that's the way I don't usually expect people to think about these kind of problems, and that's okay. This is valid, and it's true, and it's creative, but it's not usually how somebody would think when they do math. So instead, what you're probably going to do is expand the brackets, which is perfectly fine. So the second way you could do this is expanding the brackets. When you do this, you will get is equal to 4k squared. Now, unlike here where you can immediately begin to say this is an integer and then conclude it's even, here you're going to have to do one more step and factor out a 2, right? Because you need to get something that's 2 times an integer. So this is then going to be equal to 2 times 2k squared. Awesome. So we just did an extra step, and now this is where, in this case, you would argue 2k squared is an integer. Great. Now, regardless which one you chose, your conclusion should be very similar to, since a squared is equal to 2, I'll go with the bottom one, times 2k squared, where 2k squared is in fact an integer, a squared is even, so the statement is true. Fantastic. If you want to do the first way, you just simply replace this with, oh, my bad, 2 times k times 2k. And then you just argue this, you would replace that with k times 2k. That's all it is. We've now proven that the square of any even number is always going to be even.